Adding and subtracting rational expressions. Okay, I'm going to start us off with just very simple. This is a rational expression. Let's do 1/2 plus, let's say 2/3 plus, and let's go with 3/4. Now, normally what you would have done was look at 2, 3, and 4, found the lowest common multiple, which is 12, convert everything to have a denominator of 12, because in order to add rational expressions or fractions, we need a common denominator. And I'm going to do this slightly differently. And the first thing I'm going to do is I'm going to factor the denominators. So the 2 and the 3 are prime, and 4 can be written as 2 times 2. Now we have no variables here, so there's nothing, there are no undefined, no non-permissible values. And I'm going to put down a large denominator bar and say, well, from this fraction here, I'm going to need a 2 in the denominator. From this fraction here, I'm going to need a 3 in the denominator. And from this fraction here, I'm going to need 2 2's, but I already have one of them, so I'll just need one other 2. And see here, we've built up the common denominator, which is 12. 2 times 3 times 2 is 12. So now let's look back up here and say I've got a 1 over 2. So if I put that 1 down, well, there's already a 2 accounted for, so you can see that I need this 3 times 2. So that 1 is going to have to be multiplied by a 6 in order for this expression here, which is now 6 over 12, which is equal to 1/2. So we put the proper number. Now let's move to the 2. So the 2 is over a 3. I've already got a 3 here, so what's missing from the 2 is a 2 times 2 or a 4. So I'm going to put a 4 in there. And now, ignoring the 1 times 6, we have 8 over 12, and 8 over 12 is 2/3. And we're going to finish this off with the 3, and I'm going to extend the bar here. And the 3 is over 2 2's. So I already have the 2 2's here, so I need a 3, and I'm going to multiply the 3 by a 3. And so now we have 6 plus 8 plus 9 all over 12, which is 23 over 12. And so that's adding maybe a slightly different method than you may have seen in adding or subtracting fractions when you first learned that. And now let's apply that to rational expression. Okay, here's another rational expression, and in this case, again, we have no variables in the denominator, so there are no non-permissible values. We're looking to basically simplify this, which is to write it as 1. So equals, now first thing I'm going to notice here is that this 6 can be written as 2 times 3. So I'm not going to come up with an extra line here. We'll certainly do that when we get to the variable part of things. So big fraction bar, big denominator bar, and out of this denominator we need a 2 times 3. 2 times 3. This denominator needs a 2, it already has a 2. This denominator needs a 3, it already has a 3. So we have the lowest common multiple, right? The lowest common denominator being 2 times 3, or 6. This first expression, 3x minus 1, stands on its own. It's over 6. It's already got the 2 and the 3 here, so that's good to go. Minus, this has a 2 on the bottom, but now we want to write it, so it's got a 2 and a 3 on the bottom. So I'm going to have to multiply this expression by 3. So 3 times 4x plus 7. And now this expression here, because the 3's would cancel, is the same as this expression here. Plus, we have a 3 on the bottom. I'm going to extend this out a ways. So we need, what are we missing? Well, we're missing a 2. So I'm going to put the 2 here. 2x plus 3, close bracket. And if we look at each of these expressions now, so instead of actually having to write them with a common denominator in all 3 instances to rewrite this, to rewrite this, and to rewrite this, we've written it as one expression, and now we can simply go through, simplify, and collect like terms. So, first term, 3x minus 1, minus 12x, minus 21, plus 4x, plus 6, all over 6. Okay, and we can combine these now as 2 times 3. Okay, so let's collect terms. We've got 3x minus 12x is minus 9x, plus 4x will give me minus 5x. And minus 1 minus 21 is minus 22, plus 6 is minus 16, all over 6, and we're done, right? And remember, no non-permissible values. Since x can have anything, we need an x in the denominator, right? Because it's denominators that can't be 0. Okay, so these are kind of fairly simple ones, and I think they match up with the first section in the book. And you can certainly take a look at the examples in the book on page 165 and 166. And let's move on to a little more complicated adding and subtracting of rational expressions. Okay, 3x over 2x plus 2 minus 5 over 3x minus 3. There will be some non-permissible values. There will be some values of x you can't have. But our first step is to factor. So 3x, there's just common factoring here. X plus 1 minus 5 over 3 times x minus 1. Now that we're in factored form, we can get the non-permissible values. And let's throw an equal sign in here, right? Because we are simplifying. So this expression is equal to... Okay, non-permissible values. So x cannot be negative 1 and x cannot be positive 1. So x is not equal to, and we'll just abbreviate that as plus or minus 1. Now, we need large fraction bar, right? Because I'm putting everything. So the denominator is going to need a 2. It's going to need a 3. It's going to need an x plus 1. And it's going to need an x minus 1. So if we look at the 3x now, it's already got the 2 and the x plus 1. So this and this are taken care of. So it needs a 3 and it needs an x minus 1. So I'm going to say 3, then the 3x, okay, and then the x minus 1. And now this expression, the whole thing actually, is equivalent to this. Minus, okay, the 5. 5 is already over a 3 and an x minus 1, so it needs a 2 and it needs an x plus 1. So I'm going to throw in a 2, and there's our 5. That's the original 5. I'm going to extend this further, and we were over an x minus 1, so we need an x plus 1. Okay, and our non-permissible values stay the same all the way through. And remember, we need to do it here in case one of these disappears later on. Okay, let's expand this. What have we got? 3 times 3x is 9x. So let's multiply. I'm going to write that there, 9x. Multiply that by that set of brackets. Gives me 9x squared minus 9x. And here we've got a 10. Let's call it a minus 10, right? So we get minus 10x minus 10 all over. And at this point, I'm going to combine the numbers here, right? So let's go 6x plus 1. X minus 1, and finally we have 9x squared minus 19x minus 10 all over 6, and an x plus 1 and an x minus 1. And that is the simplified form. Now at this point, it might be worth pointing out that we should consider factoring this, right? What if one of the factors, well, first of all, what if this factors? If it does factor, what if one of those factors is one of these guys? Well then, just as we did earlier with simplifying rational expressions, we would have to simplify that and cancel it out. Now in this particular case, I don't think that's going to happen. So you know, this won't factor, and we don't need to worry about doing that here to see if it would cancel. But it is something that you will have to keep in mind. Okay, here we go. One of the more difficult ones, or more challenging ones. So first step is to factor. So we have the 2x minus 1 over. Now we need the factorization of this. So it's a 2x and an x. That's a plus 1, and that's a plus 3, and the only way that's going to happen is 2 plus 1 is 2x squared, plus 2x plus 1x is plus 3x plus 1. Plus, okay, 2x plus 1 over, well, this is going to be a 3x and an x And again, it looks like plus ones all around, but we will have a common. We do have this in common. And at this point, we can state our non-permissible values. So NPV x cannot be, okay, negative 1/2, negative 1, negative 1/3, negative 1. So let's go negative 1, negative 1/2, negative 1/3. Okay, so we've stated our non-permissible values. We always do that when we are simplifying. Next up, okay, so I've got the 2x minus 1. Actually, wait, no, we should start down on the bottom here. Nice long bar. I'm going to need a 2x plus 1 and an x plus 1 from here, and a 3x plus 1 and an x plus 1, but I already have the x plus 1, so I don't need that. So looking here, we've got the 2x minus 1. These two are there, so what are we missing? You got it, 3x plus 1 plus, and I've got the 2x plus 1. And we can't do, I know the temptation is let's cancel that. And let's take care of the rest of this. So this has the 3x plus 1 and an x plus 1. It's missing a 2x plus 1. 2x plus 1. Okay, now we can expand. So we're going to expand this and expand this. And let's see where that takes us. So I'm just going to move down a bit. Equals, okay, we got 6x squared. 6x squared plus 2x minus 3x will be minus 1x, just minus x, minus 1 plus, now if this were a minus, then I would be putting a set of brackets down and working this out, but it's plus. This is the square of a binomial, so it's first term squared, plus 4x squared. This times this, 2x times 1 is 2x, doubled is 4x, plus 4x. And the square of the 1 plus 1 over, and it's a long over, and these 3. And you don't get to leave stuff out at different steps. Every line needs to, have its integrity. So let's pop down a little bit more. See if I can do this. I can't write on the gray there, so. Okay, 6x squared plus 4x squared is 10x squared minus, plus 3x minus 1 plus 1, which is 0. Now, this will factor, but it would be x and then 10x plus 3, which won't cancel with this. So we're just going to leave the denominator the same. 2x plus 1, x plus 1, 3x plus 1, and this is actually number 61 in the book on page 172. I thought I'd pull that question out. You're doing the even questions. This one is odd, and but it's will be very similar to the stuff you're going to be doing in adding and subtracting rational expressions. And now you're free to fire away at that.